Hello everyone, this is Avionics, equipment of civil airplane, and today we will discuss one of the most useful digital data bus in civil aviation, which is ARINC 429. Thus we will talk about basic characteristics of this data channel and a little bit about application. First of all, let's describe specification of ARINC 429. We should note that it was developed based on ARINC 419, which was issued before in 1966. Beginning from publishing, this specification was known as the first digital data transferring on board of civil aviation. First published in April of 1978. And after that, it was firstly used on board of Airbus 310 and Boeing 757 and 767. There are different editions of this specification because during the development of electronics, requirements for data bus has been changed a little bit, which was not so significantly from the basic idea of ARINC 429. Thus, it was 19 editions of ARINC 429. And 19th edition is used today for data transferring. Also, this 19th specification was published in January 22 of 2019. And a specification includes three main parts. And first one, the most valuable because they describe the performance and functioning of this data bus. If we can compare it to USSR equipment, 1 year later, after publishing ARINC 429 specification, host 8977/79 was issued and was published and finally used on board of some USSR period historical airplanes. However, it is also very tricky that at first it was published ARINC 429 and then in 1 year we have a translation for host, which perform approximately the same capability. If we talk about basic performance of this specification, we need to mark that ARINC 429 it is a Simplex data transferring channel. It supports the two bit rates modes, low speed from 12 to 14.5 kilobits per second and high speed up to 100 kilobits per second. At physical layer, it uses return to zero bipolar two-state modulation. The data transfer is performed with the help of digital words which includes 32 bits of data. And if we require to transfer quite a long sequence of data, we can divide this data up to 255 words in one data message. That's why if data to transfer more than length of data which we can send via one data word, we can divide this data into a sequence of data words. And this specification supports the division into 255 data words for one data transferring. It supports also bus network topology with one source and up to 20 sinks. At the physical level, it uses two wires connection, which support in normal operation up to 150 feet length of line, which can be increased up to 300 feet, which is enough for modern sizes on board of airplane. Based on network topology, it can be organized as a star topology, where we have one transmitter and multiple receivers. And for each receiver, we use a specific pair of wires. In case of bus topology, which is much more frequently used, it is the most frequently used topology for ARINC 429 today. We have one transmitter, then we have two wires bus, and up to 20 receivers LRU we can connect to two of these wires parallel. And each LRU receiver can only receive and cannot transfer any data. In network can be only one transmitter. Quite valuable that ARINC 429 support multiplexing topology. What does it mean? It means that one of the LRUs in the network can use local subnetwork, and in this case this LRU we called multiplexer, because it can switch packets from one network to another subnetwork. And in this case, for example, this LRU transmitter can transmit data to another LRU with receiver, and then these packets can be switched to the local subnetwork of this LRU with multiple receivers inside, also up to 20 receivers. If we would like to organize a duplex connection, we should use two ARINC 429, because in ARINC 429 we can transfer the data only in one side. To support opposite data bitrate, we require to use one additional ARINC 429. At the signal level, you remember that data transferred in data words is binary. It means that we have a sequence of logical ones and logical zeros. At signal level, logical zero is coded by pulse of negative amplitude, and logical true or 1 is coded as a positive pulse. Transmitter use amplitude for low level and for high level at their minus 10 volts and plus 10 volts. In the receiver, during the waves propagation, during the signal propagation in the wire, level of signal can be reduced because multiple receivers can be connected parallel. That's why each receiver has some resistor. And in this case, total voltage will be reduced. Thus, at receiver side, detector use level of voltage plus from plus 6.5 volts up to plus 13 volts to identify logical 1, and from minus 6.5 to minus 13 volts for receiving logical 0. In case if we have fault in data transmission, it means wires are broken or some connectors are broken. In this case, we use 0 level. Thus, if we do not have any voltage, it means we have a broken data channel. And in the receiver side, we use levels from plus 2.5 volts up to minus 2.5 volts to detect broken data channel state. The duration of each pulse or duration of each bit of data is connected with bit rate. And if you talk about 100 kilobits data transferring mode, 1 bit time includes 10 microseconds. For case of low speed data exchange from 12 to 15.5 kilobit per second, we use 1 opposite to 1 bit rate time in microseconds. Quite important here, it is rise and fall time of pulses. In high speed mode, it is 1.5 microsecond. For low speed, it is 10 microseconds. Physical level, it is two wires twicely paired and which use metal shield which are connected to the ground. Any receiver is connected parallel to both of these wires. This is an important thing. And a few words about digital data word. Digital data word in ARINC 429 includes 5 basic structural elements. First one, it is a label which in most cases indicate a parameter which will be transferred in the data field. Then SDI, we will talk about it. In most cases, it is identification of source. Then from 11 to 29 it is data. Thus, parameter which we would like to transfer should be coded binary and placed in data field. Then sign or state bits, it is 30 and 31, and final 32th bit, it is parity bit. Label use from 1st to 8th bit, and it is important that each receiver is required to detect a label field. And inside of this label field we have a specific code which is listed in the ARINC 429 specification. For each source we have up to 255 labels that can be used. In attachment to specification of ARINC 429 we have a list of equipment. It is also important that each equipment that can be placed or can be used for data transferring has unique identification code, and each parameter which can be transferred also has unique label, and it gives possibility during the coding of ARINC 429 DDB just to specify a parameter, and automatically all performance of this data channel will be tuned for transferring this type of data. Next 2 bits, it is source destination identifier 10th and 9th bit, indicate the intended destination of the data on a multi-sync bus. In this case, we can specify only 3 addresses for LRUs: SDI 01, SDI 11, and SDI 10. SDI 00 is used for a broadcast mode in which all data which will be transmitted from LRU will be received by all other LRUs. In some modification of ARINC 429, these 2 bits can be used as an extension of label. Then, from 11 to 29, we have a data fields. Data in this data format can be transferred in different data types, and ARINC 429 supports following formats. Binary, it means transferred data will be simple coded to binary type and then put it in the data field. Next, binary decimal coding, or BCD, binary decimal coding. It uses division of the whole number into digits, and then each digit is coded by binary and put it at the specific place in the data field. In this case, if you would like to transfer some characters or symbols, ARINC 429 use ISO5 coding table for transferring such kind of textual data. Then Discrete data. This is a third type of data which can be transferred. In this case also I would like to specify that on board of aircraft we have different sources of discrete data. It means data which is transferred and can be logically true or false. Thus discrete data. Next type, it is maintains data and acknowledgement. This type of data transferring is used only during the maintenance or setting up of data exchange microschemes. It means that when we switch all LRUs in our network, then we can connect it via specific adapter to PC and then support maintains function to code transmitter and receiver microscheme for particular algorithm of operation. And also it supports Williamsburg-Buchhorn protocol for bit-oriented file type data transfers. Sign status matrix is used in case if we need to specify sign or status of transmitted data. If it sends data in binary code, in this case we use it to specify sign. Thus 0 means plus, north, east, right, up to. Logical true or 1 is used to specify minus, direction to the source, west, left, down or from. Next one, it is binary decimal data. In this case, each data field in data word can place 5 digits, each of which is encoded by 4 digits. And also I have talked that if we would like to transfer symbols or character, we need to use specific ISO coding. As an example of coding, you can see here that in some attachment to ARINC 429 we have parameter value, we have equipment code which generates this data, and we have a label. And also we have specified type of data transmission. For example, if we talk about coordinates of airplane location like latitude and longitude, we see that this data should be transferred in binary decimal form. Yep, you see it here. And also there are 3 different types of equipment can transfer this data. Data could be identical, however it can be issued by different equipment, because you know that on board we have GNSS receiver, thus it can be generated by GNSS receiver, mostly GPS. Then it can be inertial navigation system, and it can be flight management system, because you remember that flight management system analyzes the data and issue exact location of aircraft which will be used of all other systems on board, and also will be transmitted via ADS-B mode. And probably this hexal numbers of equipment 2, 4, and 38 support these three types of systems. Here in another table we can find label. Thus, for latitude and longitude, we need to use 10 and 11th number of transferred data. Then we see that range of transferred parameters from 100 north to 180 south. Then we see that it uses north direction to get position sense. We see resolution of data transferring, and we see a minimum interval between transferred data and maximum. Thus all performance and all characteristics of each parameter is specified in specific table of this specification. The same thing we have for any other parameters, like, for example, maybe acceleration. I don't know. We see units for measurements, we see scale, and we see frequency of generation this data and resolution, and also label, which is used in label field. If you talk about ISO 5, also we've got table as following, where we have a set of symbols and Latin characters, which we can use for transfer some coded data, contextual data. Let's go next. Sign status matrix. It is 30 and 31st bit in the data word. For binary coded decimal data, we use the following description of using this data. Thus, it is 0, 0, it means plus north, east, right to above, 1, 1, minus south, west, left from below. If we have 0.1, it means that there is no computed data. And 0, 1, it means that it is functional test. It means that the system is in functional test now. Then, if we transfer data in binary form, sign is transmitted at the 29th bit, and in this case 30 and 31st bit are used as a status matrix. In this case 0, 0 means failure warning, 1, 1 it means normal operation, and 1, 0 no computed data, 0, 1 it means a result of functional test. In case discrete data transmission, we see that 0, 0 it is verified data or normal operation, 1, 1 it means failure warning. Also 1, 0 it means no computed data, and 0, 1 functional test result. And finally, final bit, it is a bit for correctness data channel checking. It means that it uses a specific bit for checking if the data is transferred correctly. ARINC 429 is used at different levels, and in any case transferred data in digital world should be checked for failure. Thus, ARINC 429 uses odd parity as an error check to issue accurate data reception. It means that transmitter in each word try to count how many logical ones we have. If and add 1 or 0 at 32 bit to get odd count of ones in digital world. Thus, if we have even, it means mistake. Thus, odd parity, it means normal data transferring. Even number of ones in data world, it means mistake. And at this point, I would like to finish our talking about ARINC 429. If you have other questions, I will be glad to answer. Also, it will be glad, and I would like to recommend you strongly to try to look through the internet and find a short description of ARINC 429. And it is available for free. Thus, you can look more carefully through the specification, extraction, and you will know the basic particularities of this data channel. Also, you can try to find quite all editions of these standards. However, it is not welcome to read it, because much more useful to play with extraction of current edition, because there are some difference. Thus, thank you very much for watching. Hope we are doing well and goes to the electronic engineer in avionics. Bye, see you later.